Hello friends, today we are going to discuss a very interesting and basic topic of physics, that is mechanics. Mechanics is that area of science concerned with the behavior of physical bodies when subjected to force or displacements and the subsequent effects of the bodies in their environment. Weight is the force exerted in a body by gravity. Mass represents the amount of matter in a particle or object. The mass of matter is constant at every place. It is denoted by m. Difference between weight and mass. Weight, gravitational force of Earth. It is a vector quantity. Weight varies according to places. Its unit is Newton. Mass, a measurement of the amount of matter something contains. It is a scalar quantity. It is constant at every place. Its unit is gram or kilogram. Distance and displacement. In daily language, distance and displacement are used in the same sense, but in physics both have a different meaning. The length of a specific path traveled between 2 points by an object is distance. A displacement is a vector whose length is the shortest distance between the initial to the final position of a point. Travel distance has only magnitude, while displacement has magnitude along with the direction. It is clear that distance is a scalar quantity and displacement is a vector quantity. The traveled distance by an object is not zero, but the final displacement may be zero. Displacement of an object will be zero when the moving object comes to its initial point. Speed and velocity. Speed is the distance traveled per unit of time. So, speed is equal to distance divided by time. It is a scalar quantity and its c unit is meter second. Velocity is the distance traveled by an object per unit time in a particular direction. Velocity is equal to displacement divided by time. It is a vector quantity and its c unit is meter second. The difference between speed and velocity is that speed has the only magnitude without any specific direction, while velocity has both magnitude and direction. Speed is scalar and velocity is a vector quantity. Acceleration. Acceleration is the rate of change of velocity of an object with respect of time. Acceleration is equal to change in velocity divided by time. Acceleration is equal to final velocity minus initial velocity divided by time. In short, we minus u by time. If the initial velocity of object is u and after time t its velocity is v, then acceleration a, its c unit is m sec2 or m per second square. Newton's laws of motion. Newton's laws of motion are three physical laws that, together, laid the foundation for classical mechanics. They describe the relationship between a body and the forces acting upon it and its motion in response to those forces. 1. Newton's first law of motion. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Inertia is a tendency of matter by which it continues in its existing state of rest or uniform motion in a straight line, unless that state is changed by an external force. The tendency of an object to resist changes in its state of motion varies with mass. Mass is that quantity which is solely dependent upon the inertia of an object. The more inertia that an object has, the more mass that it has. The light object has less inertia. 2. Newton's second law of motion. The second law states that the acceleration of an object depends upon two variables, the net force acting upon the object and the mass of the object. Thus, the acceleration of an object subject to a force is directly proportional to the net force in the same direction as the net force and inversely proportional to the mass of the object. A is equal to Fm, where a is acceleration, F is equal to force and m is equal to mass. Or F is equal to m times a, force is equal to mass times acceleration. SI unit of force is Newton. 1 Newton is equal to 1 kilogram meter per second square, or 1 Newton of force is the force required to accelerate an object with a mass of 1 kilogram 1 meter per second every second. 3. Newton's third law of motion. For every action, there is an equal and opposite reaction. The force imposed by the first object to other object is known as an action, while the force imposed by the second object on the first object is known as reaction. The size of the force on the first object equals the size of the force on second object. Newton's third law of motion is also known as action-reaction law. Momentum times momentum is the product of the mass and velocity of an object. Momentum P is equal to mass m times velocity v times it is a vector quantity possessing a magnitude and a direction. Its SI unit is kilogram-meter per second, kg.m_sec. The rate of change in momentum of an object is proportional to the imposed force on an object. The change in momentum occurs always in the direction of the force. It is the other form of Newton's second law of motion. Force is equal to rate of change of momentum, means change in momentum divided by time. Force is equal to mv minus mu divided by time.